All right, welcome back. This is 3.2 Triangle Similarities. Last time we talked about triangle basics. Today we're going to try and look at two triangles and see if they are similar. And we'll also have problems where if the triangles are similar, but we're missing one side, we could figure out how to come up with the length of that side. All right, so in Unit 2, we did proportions specifically for percentages. All right, remember our kind of equation for percentages? It was part over whole is equal to percent over 100. Okay, so those are proportions. We'll be doing kind of the same sort of thing, but with triangles. Okay, so let's do a quick review of how to solve proportions. Okay, we'd use the cross product, or we cross multiply. So to do that, we would multiply A and D. A and D would give us one side of our equation, and then B and C that gives us the other side. All right, so we can just multiply across and set them equal to each other. All right, so let's do a quick review. We had problems like this on our homework and quizzes last unit. So we would cross multiply. So we do 2 times 6. That's 2 times 6. 2 times n. Okay, and then we multiply 7 times 12. All right, and that would end up giving us 84. So always simplify what's on the left side, simplify everything on the right side, and then we need to get n by itself. We would divide both sides by 2. So our answer would end up being n equals 42. All right? You could always check your answer by plugging it in. Okay, you would get 42 over 7. If you plug that in your calculator, you'd end up getting 6. And then 12 divided by 2 is also 6. So for them to be proportional, they have to be equal. All right, so that's one way you can check your answer. Okay, cross multiply again. That gives us 9x equals 4 times 11. 4 times 11 is 44. And then to get x by itself, we divide both sides by 9. On the left side, the 9 divided by 9, that cancels out. We would end up getting x equals, and I think that one does not go in evenly. Let me do that really quick on my calculator. So 44 divided by 9, that gives us 4.89 if we round to the hundredths place. Okay, or we could round to the tenths place. Let's do it to the tenths place. So 4.9. Okay, and then we have some different types of proportions. We haven't done this before, but we do it exactly the same. So we would multiply 5 times n minus 4. Now remember that 5 is being multiplied by n and a negative 4. So we'd need to have a parenthesis around those. And that would be equal to 7 times 12, or 11 times 12. Okay? So we talked about these types of problems in our last unit as well. So if we needed to solve for n, this would be like a multi-step equation. We would need to distribute. That gives us 5n minus 20 equals, and then would multiply 11 times 12. 11 times 12 gives us 132. Our next step would be to add 20 to both sides. So remember, when we're solving, we do like the opposite of PEMDAS. So we'd need to do that first. We get 5n equals 152. And then we would divide both sides by 5. Cancel would end up getting n equals 30.2. Okay, so you could plug that in your calculator, and that would be great. Okay, D is basically the same, so pause if you can, give this a shot. Okay, so it would multiply, that would give us 6 times 10 equals 12 times the quantity k plus 10. All right, so make sure you put that parenthesis in. We would multiply to give us 60. We'd distribute to give us 12k plus 120. All right, then we would subtract 120 from both sides. That would give us negative 60 equals 12k. And then we would divide both sides by 12. You'd end up getting k equals negative 60 divided by 12 gives us negative 5. Okay, so again, you may say, oh, is that right? We have a negative? So if we're ever questioning, we can always plug it back in. We would end up getting 12 over 10 equals 6 over negative 5 plus 10, which is the same as 6 over 5 equals 12 over 10. And then if you look at that, 12 over 10 is the same as 6 over 5, so we're all good. Okay, or you could plug that in your calculator. You'd end up getting 12 divided by 10, that gives you 1.5, and 6 divided by 5 is also 1.5, or 1.2. Okay, so that's another way you could make sure you got it right. So you're welcome to do that on the test if you have extra time to double check your answers. And just so you know, this video will probably go a little longer. I didn't go over every single problem, but I wanted to do that for this in case some of you want extra examples. Okay, so similar triangles have proportional sides. All right, when we're talking about proportional sides, like proportion means that we can come up with those fractions. So if we have corresponding sides, corresponding means that like if we had some sort of shape that was something like this, and then we had another shape that was a little smaller, but it had same proportions. Corresponding sides means that they're like the same side, just it's going to be smaller or bigger. Okay, so if we look at this triangle that I marked as red, these would be corresponding sides. Oftentimes, if they don't tell us what the corresponding sides are, then we can infer that those would be corresponding sides. Okay, so when we are trying to prove that they are similar, we will use something like this. Whereas the top, your numerators will go for one of your triangles, and the denominators, the numbers, we would use the other triangle. So let's just choose. Let's do big on top, and let's do small on the bottom. Okay, so we would want to write down the ones that are corresponding. So big would be 8, and its corresponding side would be 4. Then we would use another side. We could use 10, and its corresponding would be 5, so we'd do 10 over 5. And then at last, we could use 6 and 3. So as you notice, all of the smaller triangle numbers are on the bottom, and all of the big triangle numbers are on the top, and they're all corresponding. Okay, so after that we could simplify and notice that that would be 2 equals 2 equals 2. And since all of the sides are proportional, then we can say that they are similar. Okay? So we'll have problems like that where you'll need to show that they are similar by doing proportions like that. Okay? So let's do some examples. Okay, we're trying to just determine if the following triangles are similar. Sorry, this is a little blurry. Okay, so eventually, we're going to do kind of the same thing, would have some sort of fraction is equal to some other, or maybe rather than saying fraction, let's say a proportion is equal to another proportion. Okay, so there's two ways we could do this. When they give us all three sides, we can always say that the largest side of one triangle will always correspond with the largest side of the other triangle. So if we want to do big again on the top and small on the bottom, it doesn't matter as long as you are consistent. So if you're doing big on top, you have to do big on all three fractions. And if you're doing small on top, then all of the small numbers need to be on the top for the small triangle. Okay, so here we'd do 39 over 27. Okay, and then we could look at maybe the next largest. The next largest would be 33. And the next largest for the small triangle would be 22. And then you could guess the last side. Those would be proportional as well. So we would do 22 over 14. So if you notice, all of the big sides of the big triangle are on the top, and all the small sides of the smallest triangle are on the bottom. Okay? So now we would want to simplify those fractions to make sure that they are equal, kind of like we did above, where they were like 2 equals 2 equals 2. But when you do this, for this problem, we divide it, 39 divided by 27 gives us 1.44. That goes forever. If we do 33 divided by 22, that ends up giving us 1.5. And then 22 divided by 14 is 1.57. So none of the sides are proportional. Okay, so we would say that this is not similar. Okay, so that's what they're asking. That's your answer, is not similar. But obviously you have to show that it is not similar, or that it is similar, okay, for on like a homework or quiz or test. Okay, here's another example. Oh yeah, let me mention this thing over here. Okay, so this is a similarity statement that tells us what sides are corresponding. So how we use that, and you can just use what I did, using like the big to big, kind of like this, big to big, and then medium to medium, and then small to small. That works great. Or you can use the similarity statement. Okay, how that works is, say if we want to use 39, that uses side NL. Well, NL uses these letters. That's the first and third letters. The corresponding side would also be the first and third letter for the other triangle, which is EC. All right, does that kind of make sense? So if we wanted to do side LM, that has 22 on one side, LM would be the first two letters. The corresponding side would also be the first two letters. So that would be MD. And also the same as the last one, NM or MN, either way, would be the last two letters. Corresponding would also be the DC. Okay, so we can use that all the time to see which sides are corresponding, because sometimes it's not obvious. Okay, especially if we have problems kind of like this. Okay, all right, so let's do this one. This time I'm going to use the similarity statement. So we could do RS is right here. Okay, that corresponds to BC. Okay, and it makes sense because for the biggest triangle it's 100, and that would be the biggest side, and the biggest side for the smaller triangle is also the biggest number. So that makes sense that those are corresponding. So we could do 100. Actually, let's do it the other way this time. Let's do small on the top and big on the bottom. So we'll do 30 over 100. Okay, and then we can use ST and CD. So ST, that turns out to actually be the next largest, and that would be CD. So we do 27 over 90. So remember, if we're doing small triangle on the top, we need to make sure that all three tops belong to that triangle. Okay, and then we'll do the last one, RT, which is 70, and BD, which is 21. So we do 21 over 70. All right, then we just need to simplify to see if they are equal to each other. So 30 divided by 100, that ends up giving us 0.3. If we do it for the red, that would also give us 0.3. And then for the blue, what do you guess? It's also 0.3. So these are similar triangles. Similar. Okay? All right. So if you have any questions about that, let me know. Again, you can use the similarity statement, or you can just say, well, let's do the largest to the largest, and then the next largest to the next largest, and then the smallest to the smallest. Okay? All right, so let's look at some other examples. Instead of trying to prove that they're similar, now we're going to assume that they're similar and find a missing side. Okay, so like I said, the similarity statement can help a lot when you're not sure what they're talking about, because is 27 going to be bigger than our question mark or what? So it's kind of hard to say, well, does that correspond to this or does it correspond to that? So we can use our similarity statement to do that. Okay, so let's start with that. So we'd have question mark, let's say that be X. We'll just have it be on the top. So we'll do the small triangle on the top, and we need to find the corresponding side. So X, the side that has X, is PV. So PV is the first two letters. So we need to use the first two letters for the larger triangle. So that's PQ, which is right here. So we'd do X over 110, and that should be equal to, so again, since we're using the small on the top, we'd want to use 27. And you could also, you would probably assume that the other corresponding would be 90, and you'd be correct, but you could always check. So PU would be the first and third PR. So that makes sense. All right, so once we have that set up, this is what we've done in our last unit. So we'll just do cross multiplication. So 90x is equal to 27 times 110. 27 times 110 gives us 2,970 equals 90x. And then to get x by itself, would divide both sides by 90. So you get x equals 33. Okay? And you can always kind of look at that and say, does that make sense to have that be 33? And I would say, yeah, that sounds about right, okay? It looks bigger than the 27, okay? And if you wanted to, you could plug that into the proportions and make sure that works out, or, okay, there's lots of things you can do to try and make sure that you got it right. So here's another example. We want to find this side, so we'd need to find the corresponding side. So let's do x over So that would be AV would be our side, AV. So our corresponding side would be AB, should be right here. So that'd be 26. And then we'd do 12 over 24. Okay, and cross multiply. 24x is equal to 12 times 26. 12 times 26 gives us 312. And then we could divide both sides by 24. X equals, we use our calculator, divided by 24, it gives us 13. Okay, so see if you can do C by yourself. Okay, as often as you can, pause and do the problems by yourself and then check to make sure you're understanding and getting it, okay? It won't get into your brain if you just listen. All right, so same thing, this will be our X. All right, that's our P, which is our first and third. So the corresponding side would be RC, should be right here. So this one's a little different than the other one. Both A and B, the corresponding sides were like straight across, where this one, they're not. So you gotta be careful. Oftentimes they'll be straight across like those if these turn out to be parallel. Okay, they have the same slope. Okay, but they don't tell us that they're parallel, so you just have to check. All right, so we'd do X over 48 is equal to, and then since we're doing X on top, then we need to do 143 on top over 66. So big triangle over small triangle. Cross multiply, we get 66x is equal to 48 times 143. 48 times 143 gives us 6,864 equals 66x. And then we'll just divide both sides by 66. X equals, divided by 66, gives us 110. Or 104, sorry. 104. Okay, and that kind of makes sense. 104. Okay. All right, so there are some other types of problems that look a little different, but you're doing the same thing. Basically, we have two triangles that are kind of on top of each other. So we have a small triangle, and we're saying that those are similar to the big triangle. Okay? And we want to find out I should change that to a different color. Okay, so this 27 corresponds to the big triangle, and right here, that question mark, what they're asking for is that short side of the small triangle. Okay, so X, they don't give us the similarity statement, but since it's part of, like it's like a triangle inside of a triangle, these two would correspond. So we'd do X over 27, and that should be equal to small over big, so 14 over 21. All right, and then we do our cross multiplication. We'd get 21x is equal to 14 times 27. 14 times 27 gives us 398. And then we would divide both sides by 21. And that would give us 18. X equals 18. Okay? So same thing. If you feel comfortable, you can kind of go forward. You don't need to watch the whole thing. So here we're trying to find the big side of the big triangle. Okay? So again, these would correspond. These would correspond. And they actually give you enough information to use this side if you wanted to instead. So you have a choice. You don't have to do all three. So let's just use the red. Okay, so we'll do x over its corresponding side, which is 24, is equal to 88 over 16. Okay, so if we're using big triangle over small triangle, we need to do big over small. Okay, so this would be like our big, this would be our small. Okay, small, big. Okay, got it? So then we do our cross multiplication. 16x is equal to 24 times 88. 24 times 88 is 2112. And then we divide both sides by 16. So x equals 132. All right? And you could kind of look at that and say, yeah, that sounds about right. If you had something switched around, like if you had like you accidentally did something like x over 24 equals 16 over 88, you'd end up getting some, let's see what we'd get, 88 times 24, you'd get something like 4.3, and there's no way that this big long length right here could be 4.3, okay, because that is longer than 24. So always check your answers, or at least look at it and see, does that make sense? Okay? All right. Here's one more. If you look at that, that's a nice isosceles triangle. We have 9 and 9, okay? So that side is congruent to that side. And since they're similar, the big sides have also to be congruent. So this would be 18. But let's do it the other way. So if this was x, we'd do x over 9, because these would be corresponding. And then we'd do 18 over 9. Okay, so we do, since x is our big triangle, this would need to be our big triangle as well, so that's why it's 18. Okay, cross multiply, you'd get 9x equals 918, 9 times 18. You could do 9 times 18, and then that gives you 162 equals 9x. And then we would end up getting x equals, what do you get? 18. Okay? So that one's kind of nice. It kind of looks like a face. Hi. Okay? All right, so feel good about that. Just, we'll be doing proportions, okay? I always like to have my x's on top. It doesn't matter if you chose to do x's on the bottom, that's fine, as long as you keep like the same triangle on the top and the same triangle on the bottom. Whether it be small on the top or small on the bottom, it's fine. You just got to be consistent. And I wouldn't switch things around. I would just choose what you're going to do every time and then just stick with it. All right, scale factor. So scale factor is basically if we have these two triangles, like these ones, and what would we need to multiply one of the triangles to get the second triangle? Okay, since they're similar, I mean, they are proportional, so if you multiply all the sides by a certain number, then they would all get big at the same amount. So scale factor does that for us, okay? A good example of scale factor in the real world is maybe if you needed to take a picture of a person and then zoom it or blow it up for like a billboard, okay? So obviously the picture of the person on the billboard is going to be much bigger than the person in real life. So if k is greater than 1, the image is enlarged, or the shape is enlarged. The triangle gets bigger. Okay, if the scale factor is less than 1, it's reducing. A good example of reducing or downscale something would be like a map. Okay, obviously maps have a scale factor, and it usually will tell you on the map, like it's like each inch in the map is worth 10 miles or something like that. So it's been reduced a lot. Okay, so there's some examples. If k equals 1, and then it's not enlarged or reduced, it would just be the original picture, okay, or shape. So let's do some of these. They want us to find the scale factor. So how we do the scale factor is we do the second shape divided by the first shape, okay? So if we're trying to do that, we would say, well, this would correspond to this. This would be our second shape, and this would be our first. So we'd do 49 over 14. That would be our scale factor. And then just simplify it. I think it gives you 7/2. Okay? So if you multiply 14 by 7/2, you end up getting the bigger, what is that, trapezoid? Okay? And it doesn't matter which one you do. If you wanted to do 70 and 20, you could do k equals 70 over 20, and that would also give you 7/2. Okay, but you only need to choose one. So B is another example. You could do 70 over 40. So k would be 70 over 40. That gives us 7/4. Okay, so if you multiplied 40 by 7/4, you would get 70. So what do you need to multiply the first image to get our second image? All right, and you could do the same with 35 divided by 20. That also gives us 7/4. Here's another example. Obviously, if we wanted to use our scale factor, we can't use 28 because we don't have a number for that to do the scale factor. So we could do 30 divided by 40. So second image, k, is equal to the second image, or second shape, divided by the first shape. And that would give us 3/4. Okay? Like if we didn't simplify that and we multiplied 40 by 30 over 40, well, the 40 and the 40 would cancel and we just have 30. So that kind of makes sense. Scale factor. Okay, and this one would be reduction. Okay, because k is less than 1 and the shape gets smaller. Here this would be enlargement. Because we multiply the first image and it becomes bigger. All right? An image of this is what I kind of talked about before. An image of a celebrity is going to be on a promotional billboard. The person is 5.75 feet tall in real life and 11.5 feet tall on the billboard. What is the scale factor of this dilation? So again, we do second image, so 11.5 divided by 5.75, and that would end up giving us a scale factor of 2. Okay, if you multiply 5.75 by 2, you end up getting 11.5. All right, given the two figures are similar, so they're telling us that they are similar, find the missing links. And we kind of did one like this before with triangles. You can do the same thing with pentagons, or not pentagons, polygons. Okay, so these are all set up, nothing tricky about it. So we'd do x over 14, so x over 14, those would be corresponding sides. And then we could do 8 over 16. All right? And you know how to do that already, so cross multiply, solve, you'd end up getting, no, let's just do it. So we get 16x is equal to 8 times 14. 8 times 14 is 112. And then we would divide both sides by 16. That would give us x equals 7. Okay? Which kind of makes sense because 8 is half of 16. So the scale factor here would be 1/2. So we'd do the same thing here. Half of 14 ends up giving us 7. That kind of makes sense. So I guess if you wanted to, you could do the scale factor. I mean, that's really what that is the scale factor is 1/2. All right, B, same sort of thing. We could do x over 24 is equal to 12 over 9. Okay, so we have the big on the top, we have small on the bottom for both of the denominators. Okay, and then we would just need to cross multiply and solve. So 9x equals 12 times 24, which is 288. Divide both sides by 9, and you get x equals 32. All right. Hopefully you're pausing and trying to do this if you watch this video, okay? Okay, here's another example. This is kind of like a real world situation. Say you were outside walking around and you know yourself that you are 5 feet tall, okay? And you measure, I'm not sure, maybe you have a measuring tape or whatever, or you just pace, you could use how many feet you have, okay? We're just going to say it's 7 feet, okay? And then we have this other tree that you could measure the shadow because you could run your ruler or whatever and see how many feet you get. So you get 14 feet, but you're not tall enough to measure the height of the tree. Okay, and you want to know how tall that tree is. Okay, maybe, I don't know, there's an airport and the trees can only be a certain amount of height. Okay, and so you need to calculate that. So you could just use proportions. Okay, so x, this height corresponds to this height. So x over 5 would be equal to 14 over 7. So we do big over small for this case. Okay, like I said, you could always do small over big and you'd be fine. Cross multiply, 7x equals 70? Yep, 70. And then you'd end up getting x equals 10. So the height of the tree is 10 feet. Okay, no way you could have measured that because you're not tall enough. Okay, but now you know how tall the tree is, which is kind of cool. All right. All right, and then we have some of these other shapes. Same sort of deal. Looks like some of these got mixed up. Obviously, if you're trying to find the missing side, and oh yeah, we can do that one. Never mind, let's do it. I was missing that x. Okay, so we'll have other types of problems where you do the same sort of thing, except instead of just having x, we'll have 3x. Okay, so 3x corresponds to 7, so 3x over 7 is equal to, and we could choose whichever one you want. You could do 12 over 4, or you could do 24 over 8. I kind of probably would prefer to do the smaller sides. Okay, so here we'd end up getting 4 times 3x equals 7 times 12. That would give us 12x equals 84. And then we can divide both sides by 12. And you get x equals 84 divided by 12 is 7. Okay. Another example, instead of having like 3x before, now we have subtraction. So, but you do the same sort of thing. That would correspond to 3. So x minus 1 over 3 is equal to, then you could do 8 and 4. Okay, cross multiply. You'd get 4 times, and now make sure you have parentheses when you do that, because if you just did the x, and then you'd have 4x minus 1, that wouldn't be the same. So we need to make sure we use the parenthesis and distribute. Okay, that would give us 4x minus 4 is equal to 24. We'd subtract 4 from both sides, so again, we kind of do opposite PEMDAS, adding and subtracting first. Or so that'd be adding, add 4. You get 4x equals 28, and then we could divide both sides by 4. We get x equals 7. Okay. All right, last one, just kind of combines those two, so now we have multiplication and subtraction. So but you'd kind of do the same sort of thing. This corresponds to this. This, maybe we'll do 6, corresponds to 12. So 2x minus 8 over 8 is equal to 6 over 12. Cross multiply, that would give us 12 times 2x minus 8 equals 6 times 8. 6 times 8 is 48. 12 times 2 is 24x. And 8 times 12 is 96, so negative 96. We would need to add 96 to both sides. Would get 24x is equal to 96 plus 48 is 144. And then we can divide both sides by 24. You get x equals 6. All right? So most of your problems, just, that's another thing, is you've noticed all of the answers are whole numbers, okay, or integers, so no decimals, except maybe when we have our proportions, or our scale factors, I mean. Sometimes we have fractions that way. But when we're doing sides, that's kind of a hint that we always get whole numbers, okay? If you get decimals, maybe double check, make sure. All right, graphing and dilation, or graphing dilations, okay? So scale factor, kind of like we talked about scale factors, is what you need to multiply to get the second image, or second shape, okay? So like here, if we multiplied 40 by 7/4, our scale factor would end up getting 90. Okay, so that is a dilation, taking it from the first shape to our second shape. That is a dilation. So we have some problems like this where we want to dilate a shape. Okay, and the way we would do that oftentimes is using coordinates. So I would first start by plotting our shape. So t right here would be -2, -1. So remember, we do x's first. So we go over, or we go left 2 and down 1. That would be our t. We label that. And then u would be -1, +2. And then our last one is 2, 0, which would be our v. Connect the dots, and we have a triangle. All right, but we want to dilate it, or use our scale factor of 2. So we're going to multiply everything by 2. So oftentimes when we have our new coordinates, we will write it as t prime after we dilate. So 2 times -2 gives us -4. 2 times a -1 gives us a -2. We have u prime, which is 2 times -1, which is -2. And 2 times 2 is 4. And then v prime, we would have 2 times 2 is 4, and 2 times 0 is 0. So now we would replot in our new coordinates. So negative 4 comma negative 2 would be right here. That would be our t prime. And then u prime would be negative 2, 4, which is right here. And then v prime would be right here. And we would draw our triangle and we'd be done. Okay? So another example would be, this would be, our first one was enlargement. So the second image is bigger. Let's look at an example of where it is reduced. So now our scale factor, k, is 1/2. So we'd first start by graphing. So negative 2, 1, that would be v. W would be negative 1, 4, which is right here. 2 comma 2 is right here, would be our x. And then 0, negative 3 would be y. We would connect the dots. Okay, and now we want to do the dilation. So we'll multiply everything by 1/2. So v prime, actually let me use a different color. V prime would be negative 1, because 1/2 times negative 2 is negative 1. And then we'd have 1/2. W prime would be negative 1/2, comma 2. X prime would be 1, 1. And then y prime would be 0, comma negative 3/2. Alright, so we'd replot that, would do negative 1/2, which is right here, that would be our v prime. Would do negative 1/2, 2, which would be right here, w prime. X prime would be 1, 1. And then y prime would be 0 and negative 3/2. Which would be our y prime. We'd just connect the dots again. And we just found out half of this, I don't know, maybe it's a kite, kind of that shape, is reduced by 1/2. All right, so here's just some other examples. So we'd plot it first. 2, negative 2, negative 1, 2, 0, 2. Oops, that would be backwards. Oops, sorry. Negative 1, 2, 0, 2 would be here, and 2, 0 would be here. So this is our shape. Okay, so that would be Q, this would be R, S, and T. Now we're going to multiply everything by 3/2. So Q prime would be 3 and a negative 3. R prime would be negative 3/2 and 3. S prime would be 0, 3. And T prime would be 3, 0. So I'd use maybe a different color. We'll do red again. So we'd do 3, negative 3, be Q prime. Negative 3/2, 3 would be right here, R prime. And then S prime would be 0, 3. And then T prime would be 3, 0. Okay, so we enlarged our, kind of looks like, well, it's some sort of polygon, by 2. One way you can always check that you did this right, okay, is if you drew a line from the origin to the point, it should be like a straight line for all of the points when you dilate, okay? So if the line isn't straight, some of the points are not on it, then you probably made a mistake. All right, and then 1/4. Okay, we do -1, -2, that would be our M. 2, 2, which is right here, would be our L, and then 2, -1 would be K. So we have this sort of shape. And we want to multiply everything by 1/4. So M prime would be -1/4, -1/2. L prime would be 1/2 and 1/2. And K prime would be 1/2 and -1/4. Okay? So let's do that. So -1/4, -1/2, which would be maybe about here. 1/2, 1/2 would be like here. And then we'd do 1/2 minus 1/4, which would be like right here. Okay. All right. Okay, and again, if you wanted to, you could do those lines. They should go through all of those points. Okay. Anyways, and then we didn't do this in class. We'll probably talk about this tomorrow. Okay, but word problems. Alex made a scale model of a house. Okay, the house scale she used is 2 inches for every 3 feet. So this is our scale factor. Okay, would do 2 inches over 3 feet. Okay. If the house is 12 inches tall, like the model house would be 12 inches tall, how tall is the house in real life? Okay, so here we have, instead of having like small triangles and big triangles, here we have small house, big house. So here we have our small house and we have big house. So they give us 12 inches as how tall the small house is. And we want to find out how big the big house is. So we use those proportions, cross multiply. We get 2x is equal to 3 times 12. That gives us 36. And we divide both sides by 2. We'd get x equals 18 feet. So the house is actually 18 feet. Let's do another example. The person in line in front of you at the store is buying reading glasses that says 2.75. If that is the magnification level of the glasses, how tall on to the nearest thousandth of an inch will 16-point font, which is 0.222 inches, will appear? Okay, so basically, 2.75 is our magnification. So if we had like our original and our magnification, could be our proportions. So originally, let's say it's 1, but the bifocals magnifies to give us 1.75. And original font is 0.222. We want to know how big that font is going to appear. So we do cross multiplication. we get 1 times x is x equals 0.222 times 2.75, which kind of makes sense. Okay, this is our font size, and we're just going to multiply it by that scale factor. Okay, so 0.222 times 2.75 gives us 0.6105. Okay, or if we rounded to the 10th place, we'd say 0.6. Okay. All right, so it looks like the font now looks like it's almost more than 1/2 of an inch, which is quite a bit larger. It's like triple times almost. Okay. Number 3. A copy machine is set to enlarge an image by 240%. The original image is 4.5 inches tall. How tall will the enlarged image be? Okay, so again, well, this is almost like percentages. We could do percentages, or we could do, I mean, it's the same thing doing, it's the same thing, okay? So here we'd have our percentage, which is 240, and we have our 100. And then this is our original, okay? So this would be 4.5 on the bottom, okay? So, and when we multiply it by the multiplication, it's going to get bigger. So this is like our big, and this is our original. This is our original, this would be our big, and we want to find how big it's going to be after it's enlarged. So here we'd get 100x is equal to 4.5 times 240. Okay, so 2.5 times 240, 240 gives us 1080, and then we'll divide both sides by 100. That gives x equals 108. Okay, or I think I messed something up. What did I do? That's really big. Oh, yeah, sorry, it should be 10.8. 10.8, sorry about that. I just did that in my head, and I did the decimal wrong, okay? So 10.8 inches. All right, 4 and 5, give 2 real-life examples of scaling up. So I kind of talked about a billboard. Okay, so if you had an original picture of a person, and we scale them up so he's so big, you could even look at his nose hairs. Okay, another example could be something like a cereal box. Okay, oftentimes on cereal boxes they magnify it, or they enlarge the image so that you can see the texture. 2 real-life examples of scaling down. Scaling down, so we take something and make it smaller, could be like a figurine. Okay, like you take Iron Man and we scale him down a lot. Okay, models. Okay, oftentimes if you go to like a shop to make a model, I don't know if any of you have ever done that, but they usually will say the scale factor is like, so you can see it's like 1/100th of the actual battle cruise or something like that, okay? Which is kind of cool. So those would be some kind of 2 examples, okay? All right, well that's everything. That took a while, sorry about that. If you have any questions, let me know. I'll be around all year, okay? We'll see ya.